This lesson is on logarithmic functions. This is section 3.2 from your book. So in the previous chapter, we learned about exponential functions. These functions are defined as f of x equals some b to the x. The inverse of f of x equals b to the x, the inverse of that specific exponential function, is called the logarithmic function. So this is the inverse of b raised to the x is a logarithmic function, and we write that as log sub b times x, or we read this as log base b of x. That's how we say that. So you have log base b of x. That is the inverse of b raised to the x, and we call this a logarithmic function. So in the past we learned that the inverse function reflects about the line, specifically y equals x. So whatever inverse we have, we're going to create a reflection about this line, right? If this is our original, and this is our f to the negative 1, they're the same about this line y equals x. Because they are inverses, this is also true with f of x equals b to the x, and f inverse of x equals log base b of x. So these two are going to be the same as each other, except they're going to reflect around that y equals x because they are inverse functions. So here's what that looks like. If we have if we have f of x equals b to the x, we learned what that looked like from exponential functions. Well, the inverse of that is going to be the same, except reflected about that y equals x line. So given a function, we can write it in either logarithmic or exponential form. So this is given one function, we can write it two different ways. So we said before that log base b of x is actually the inverse of b to the x equals y. So it should be clear how you would write that, right? We did inverses before, we just swapped. So this is b to the y equals x. That's the same as this. B to the y equals x, this is a very important thing to know, is the same as log base b of x equals y. So these three terms you're looking at, b, x, and y, this is how they would show up in another way. We can write that two separate ways. Exponential form is b to the y equals x. Logarithmic form is log base b of x equals y. So let's evaluate a couple. Let's do some examples. So if we're given log base 3 of 81, what do we know? We know b to the y equals x. Let's keep that in mind. So this is the same as 3 to the y equals 81. We can rewrite that, right? Given log base 3 of 81 equals y. Well, if we know 3 to the y equals 81, we can change that 81 to also have a base 3, so we can look at what that exponent is. So for this example, we have 3 to the y equals 3 to the 4 raised to the power of 4. That's 3 to the 4 is 81. So if we get that, we know y equals 4. If we have 3 to the y equals 3 to the 4, y must equal 4. So therefore, when we are evaluating that logarithm, we have log base 3 of 81 equals 4. Because b to the y equals x, 3 to the 4 equals 81. So we have to be able to break that up and look at that in two different ways in order to solve these problems. Let's look at another one. If we have log base 5 of the square root of 5, again, we know b to the y equals x, so we're going to use that. This is the same as 5 to the y, that's our base to our y, equals square root of 5. So we have 5 to the y is equal to 5 to the 1/2. That's just what square root of 5 mean. It means 5 raised to the 1/2. Therefore, we have y equals 1/2. That's our log base 5 of root 5 is equal to 1/2, because 5 to the 1/2 is equal to square root of 5. So some basic properties of logarithms, and again, these are all just sort of building on this b to the y equals x business. If you have log of any base, log base b, for any b greater than 0 but not equal to 1, and you have log base b of 1, you're going to get 0. Well, why is that? We can break that up, right? This is the same as saying b to the 0. Obviously, that equals 1. How about the next one? Log base b of b equals 1. What is this saying? This is saying b to the 1 is equal to b. How about log base b of x? That's equal to x. This is the same idea, right? We're taking this base raised to this power, and we should get this. So b to the x is equal to b of x, b to the x. Let's look at another example. So you have log base 5 equals 125. So you can use some of these rules up here, right? These are the same rules we're just building on. You get log base 5 of 5 cubed. 5 cubed is equal to 125, so we're allowed to replace that. And then we know that we just are looking for that y value. That's going to equal 3. How about 12 log base 12 to the 4.7? This one's a little more confusing, right? But we have this last one that right here. If you have b raised to the log of b to the x, that equals x. Does that make sense to everyone, I hope? So if you have 12 raised to the log of 12 of the 4.7, so this is the thing that's going, if we have 12 raised to log base 12 of some number, then our answer, when we evaluate this, is that number. We're just going to be left with x, provided that that b is the same. The b out in front is the same as your base. So some more common logarithms. Again, you have to remember log base b of x equals y is the same as b raised to the y equals x. So some common logarithms, a lot of times you'll see logs without any base, like this one. We just have log base something of 1. Well, if the base is not provided, it's assuming a base of 10. So here are some more examples of common logarithms using the properties we've already looked at. So if we have log base 10 of 1, that's how you'd read that, equals 0, what is that saying? That's just saying 10 to the 0 equals 1. How about this one? Log base 10 of 10 equals 1. Well, that's saying 10 to the 1 equals 10. These are the same rules. We really care about this b to the y equals x, because it's the same as log base b of x equals y. So a logarithm with base e is called the natural logarithm. So we said before that e is a very common base for exponents. Similarly, it's a common base to use for log. And it's so common that it gets its own special log name. It's called the natural log. And we denote that as ln, natural log. So given this problem here, if you just see ln of a, natural log of a, that's the same as log base e of a. And again, you need to remember log base log base b of x is equal to y is the same as saying b to the y equals x. So we can do this the same with our e to the 0, with our base e, right? This is the same if we have natural log. The way that this becomes is e, because our base is e, to the y equals x. So let's look at natural log of 1. That's the same as saying natural log of 1 equals 0 is the same as saying e to the 0 equals 1. Natural log of e equals 1 is the same as saying e, our base down here is essentially e, right? So we have e to the 1, well, we get e. Again, if we have natural log of e to the x, we're going to get x because e to the x equals e to the x. So let's evaluate a couple more expressions. We'll do some more examples. If you're given natural log of e raised to the 0.73, well, this is the same as just, we remember this rule from above, natural log of e to the x equals x. So if you have natural log of e to the anything up here, that's going to also be out here. So we have x, for example, it equals x. If we had natural log of e to the 200, that would be 200. That's how we would evaluate that. That's a pretty easy one to remember. So again, you have e raised to the natural log of 6. That's going to equal 6.